Position, displacement, and distance. Study this map closely. You'll notice the names of students on my wall of fame. Now tell me how to get from the corner of Ben and Lucas to the corner of Nabil and Andrew. Stumped? Probably need that map again, right? Well, let's change the names of the streets and we'll try it again with this map. Looking at it closely. Now tell me how to get from the corner of 4th Street East and 3rd Street South to 3rd Street West and 2nd Street North. You don't have to look at the map. Well, you wouldn't need to look at the map because you can kind of picture it in your head. You could just say go 7 blocks west and 5 blocks north. In order to easily communicate where something is, we will use coordinates, like x coordinates and y coordinates. To use coordinates, we have to first agree on the following things to advance: the units that we're using to measure the distance. Are we talking blocks, miles, meters? In physics, we're going to use meters. The location of an origin. Where is position 0? What is left? What is right? What is up? What is down? Which one is positive? Which direction is positive on the x and which is positive on the y? In physics, we can let positive directions be whatever we want them to be, as long as we agree on it in advance. And the way we agree on it in advance is to make a note. Pointing up with a little plus sign would mean that up is positive. Y can be horizontal and x can be vertical, if that's what's agreed upon. Despite this, x and y always need to be perpendicular. The center is the origin. Positive x is to the right, positive y is upward. Each square represents 1 meter. Now that we have the conditions set and agreed upon, now we can figure out some information about I and F. We can tell how far away they are. We can tell how long the path was that this person traveled, if going from I to F. A person starts at position I for initial. Person travels the path shown to point F, which means final. The person's initial position is 4 meters to the left and 5 meters below the origin, which is -4, -5 in the x, y coordinate system, right? Person's final position is 4 meters to the left and 3 meters above the origin. However, we can more easily communicate this position as I equals -4, -5, and F equals -4, +3. In physics, negative and positive values indicate direction. Negative and positive values indicate direction. The distance traveled would be 22 meters. If you count up all of those blocks, you'll see that. That is the length of this blue path. The person's displacement is 8 meters upwards. Other ways to express the person's displacement: 0 horizontally, 8 meters upwards. Displacement, remember, is the distance from your starting point to your ending point, including direction. So because our displacement is up, our displacement is positive, so it's 8 meters, +8 meters, or 8 meters up. Multiple ways to represent that. If you're confused on distance versus displacement, imagine a rocket being launched from Cape Canaveral, Florida, going up 100 kilometers, and then it comes back down, and it lands exactly at Cape Canaveral. The distance the rocket traveled would be the 100 kilometers up, plus, let's say, 1 complete revolution around the Earth, and then comes back down, because remember, as a rocket goes upwards, the Earth is spinning below it. So it can't just go up that high and then come back down and land in the exact same spot. It would land in a different spot, so it would have to completely go around the Earth. So if a rocket goes all the way up 100 meters, 100 kilometers, goes around the Earth one time, and then lands back exactly at the launch pad, the total distance would be the 100 up plus the circumference of the Earth plus 100 meters down. a huge number, right? Meanwhile, its displacement is 0, because displacement is the path from the starting position to the ending position. And if there was no change in that position, if it started and stopped on the same exact spot, then the displacement is 0. Again, we use delta to represent change. We calculate change by subtraction. That means delta denotes difference. To calculate displacement, or delta x, calculate the final position minus the initial position. Delta means change. Change is final minus initial. To calculate average velocity, delta v. Delta means change. Change is final minus initial. The initial position in this example is -2, +4. The final position is +2, +1. The displacement of the object is 4, -3, meaning that the object is 4 meters to the right and 3 meters below its initial position. It's this straight line. You can even use some trigonometry or geometry to figure out the exact length of this, right? Or basic arithmetic if you wanted. Initial position, final position, subtract the final minus the initial horizontal position to get your horizontal displacement. So to figure out how far left we went, we're subtracting the final minus the initial, and the initial is negative, so we're subtracting a negative, which is adding a positive, 4 meters. Now for the vertical position, we're going to subtract the final minus the initial. The initial is larger than the final is larger than the initial, so we're going to end up with a negative number. Displacement, therefore, 4 meters in the x direction, -3 meters in the y direction. If that confused you, if I confused you, rewatch it again and just do it on your own with the sound off. That may be more useful.